So this presentation actually was created by Mark Coral at Treveni. He was going to come and present it, but circumstances prevented. He's actually moving this week, so I'm doing it instead. Mark and I have very different styles for creating PowerPoints and presenting them, so I'll try to do it his way instead of my way. Okay. Does the clicker work? Yes, it does. So ATSC 3.0. ATSC 3 standard was released in January of this year. There's over 20 specifications. I think it's something like 23, maybe, close to that. Lots of tools. You know, it's a set of standards, it's a toolbox. You figure out what you need to do, what tools you might need, and the standards tell you how to use those tools. It's not cast in concrete. There are revisions. It's new. It's very new, very different technology. Guarantee that there's some things not quite right in there. So there is some tweaking going on as people build. From what I've seen so far, it's minor tweaks, not major tweaks. But the other thing with the ATSC 3 standards is they weren't meant to be the same forever. We recognize the world is evolving, technology is evolving, these standards are built to evolve and evolve gracefully. So the FCC has allowed transmission of ATSC 3.0. One of the key parts is the bootstrap. It's kind of a unique concept for broadcast television and most kinds of broadcast. The bootstrap basically tells the receiver what it's seeing, what revision of the standards, a number of things like that, and when the next thing like this will come, which allows evolution of even the physical layer. You can change the RF layer over time, and old receivers will be able to find what they understand, new receivers will find what they understand. So it's a very different concept. People are building things quickly. There are lots of solutions available now, and given that this thing was released not too long ago, this is actually quite good progress. You can get audio-video encoding solutions, segmentation and packaging, route or MMT encapsulation, signaling and announcement, and scheduler and broadcast gateways. I'll go into the architecture in a bit. These words may seem foreign to you, but the basic functionality is pretty similar to what you're used to, even in ATSC 1. Just got different names, different ways of doing the same kind of thing. Okay, and I forgot, test and measurement is also available. What's that? Transmitters, yeah, that too. Remember, Mark did this. He's not used to the RF side of the world. And most of this stuff can be virtualized. It's a little bit interesting, because when I first got into this, broadcasters didn't like computers. So most of the equipment they bought, encoders, multiplexers, things like that, were computers, but they were packaged in a way that made them look like appliances. Now, computers are everywhere, people are used to them. When you get into computers, you can start thinking about virtualizing. You know, the word cloud comes up. You can run functions on different boxes, and you don't need to have a box per function anymore. This can make for very interesting economies of scale in architectures. Let's see. And the things that can't be virtualized now will be in the near future. So what do you want to build? What is it that you actually want to do? Since these systems are network software, really it's the business requirements that are a limiting factor. And we go back. Key things are you can start off with a small implementation and grow into a full-scale big thing by just adding functionality, adding more virtual servers, more components here and there. You can do whatever you'd like. The flexibility is there for broadcasters, which is kind of new. So here's an example of an ATSC 3.0 system. Even with this new projector, I'm pretty sure most of you can't read it. I think these things will be available later. I'll be going through bits and pieces. But with a few exceptions, most of this is what you're used to. You know, content comes in over here, gets manipulated, gets packaged, gets tossed off to the RF gear and the transmitter, magically goes across the air, and receivers take it apart, put it back together again, decode it, and display it. So this upper part is pretty much business as you're doing now, just using different words, different connectivity types, and so on. One big difference is that there's also broadband path. ATSC 3.0 is a hybrid system. Components can be delivered over broadcast, can be delivered over broadband, and put together, synchronized and all the rest. So that's part of this picture. And I'm going to take you, well, other things. It used to be all the connections that you found within the station were a hodgepodge. ASI was real common for a while, SMPTE 310 for part of it, so on and so forth. Now it's simple. Not only is the transport all IP, but all the wires in the station and between here and there are IP. There's economies there. It's a little bit different technology. It's something that you have to get used to. Making an IP connection is a little bit different than an ASI connection, but it works and it's cheaper. IP is used all over the world. All the networking, all the internet stuff is all based on IP. If you look at the cost of an IP card for a PC, even though there aren't any cards anymore, it was dirt cheap compared to an ASI card. Okay, that was the wrong button. So I'll just step through some of this, just to give you an idea. I'm not going to go into gory detail, but you still have to encode stuff. You still have uncompressed things at the start, typically higher quality uncompressed things these days, but you have live sources, you have stored sources. You've got to encode them. You've got to do the video encoding. Today it's HEVC, maybe scalable if you're into that thing. Audio, AC4, at least in the United States. If you're in Korea, it's MPEG-H audio. You take these encoded streams, if you will, and you package them and segment them. You got to chunk them up, no matter, even the old system, you broke it into MPEG-2 transport stream packets. Today, it's segments. So you've got to figure out how to break them up into the right thing. You have to paste them, intersperse them, because you can only have one bit on the wire at any given time, if you will. So you need to do pacing, and then you send it off to something that gets it out to the transmitter. Rate control is taking place all through here. There's a couple of new things. You have the capability for doing dynamic ad insertion or dynamic content insertion at the receiver. So you need to be able to tell the encoder where nice places to allow this to happen might be. Other than that, it's actually pretty similar to the old system, just different technologies, but the same general concepts. And if you happen to be running in parallel, like many will be for quite a while, much of the stuff can come out into MPEG-2 transport into ATSC1 multiplexers. You still have signaling. You still got to send metadata to tell the receiver how to put bits together again. You also have advanced emergency alerting. So this is all the metadata stuff. Emergency alerting down here, signaling coming from wherever. Announcement, the listings, what's the program guide. This is still part of the system. They all get encoded. These days it's all stuck into XML instead of binary as we used to do. A little bit less efficient, but a lot easier to manipulate and a lot easier to read and a lot richer and a lot more flexible. And off it goes to the broadcast gateway. One part of this, it's not an afterthought anymore. What NRT, non-real time, push information, sending files, sending data. is a core part of the system. Not only for things other than audio and video, but actually components. Example, the announcement information, the stuff for the program guide is pushed data. The advanced emergency alerting allows rich media to be pushed. So push is a key part of the entire system these days. And again, off to the ATSC1 system if you want. NRT, I just talked about this a little bit. It's a key part of the system. It's all throughout. You have the need to pick out what goes and when it goes. So you have a scheduling component. You have to break it up into chunks like you always did. It's now done with the route encapsulator as an example. ESG and so on fits into there, all goes to the broadcast gateway. That's if you're broadcasting. This stuff can also be pulled over the internet, over broadband. So you have a parallel path for a lot of this coming out of the scheduling into an origin server, which is sitting on the internet, and a receiver can reach out and pull data. Back off. This is a little bit jumpy, isn't it? So that's all in the station, that's all the bits and bytes, and now we get into the RF portion, broadcast gateway. Still have an STL. The STL is a little bit different looking than what it used to be. Quite a bit different looking. That's what Merrill's been spending a lot of his life on, getting it right. You know, little things like SFNs. I just lost the acronym. SFNs are a big part of the picture now. The system is designed to allow relatively easy implementation of SFNs. The STL has to allow for all the information to get to all the transmitters at the right time in an SFN environment. Lots of other things. What did I do? Did I do that or did it do that? Okay. Whatever, it's a computer, it does what it wants. Okay, so we have the STL off to an exciter, off to a transmitter. And again, the internet's part of the picture. It is a hybrid system, so you have broadband delivery over the internet. And then you have receivers. Receivers are going to evolve. Right now, there's not that many on the market, although in Korea, you can walk into a store, buy a TV, and it's ATSC3 ready. They've been broadcasting for a while. There are gateways that are coming along, which allow reception of RF and ATSC3, and over Wi-Fi in the home, you can start receiving, displaying, tuning, directed by tablets, phones, smart TVs. And companion devices are part of the picture. So when you have all this kind of environment, and start looking at services, you can start thinking about services a little bit different. Television, up until recently, especially from the viewpoint of advertising, was sort of, I've heard it referred to as shotgunning or spray and pray. You send stuff out, you have no clue what it's going to land on. You know, everybody gets the same thing. If you did things right, maybe you hit enough people to be interesting. But it was sort of a one-way system. You sent it out and off it went. Today, so you've got, you know, the stations operating are going to select content, they're going to format content, they're going to send it off into a distribution pipe, could be over the air with ATSC3, with multiple pipes, PLPs or LDM. The internet is part of the picture, so broadband is part of it, MVPD, retransmission on cable systems. So there's many ways of getting things to the home. Then people consume. So far, it's pretty much the way we've always done it. Difference now is there's a return path. There's capabilities of learning what people are watching. And those that are actually thinking about this, couple cautions. Privacy is a big deal. Anonymous collection is a big thing. If you do that, you might want to explain to people what anonymous means. So keep that in mind. But you can collect information about consumption metrics, reception characteristics, what kinds of receivers are out there. You also have information available to you about distribution costs. While there's all these different ways to send things out, there's a cost associated with each. Broadcasting, you get the broadcast economies of scale. Internet, broadband, it's pretty much each bit costs. There is no parallelism, there's no multicast over the internet. MVPDs, got different business contracts, so there's different costs. And then if you're doing a business, you can set up rules, you can have receiver models. And then you can take this and turn it back into the content selection and formatting function. If I remember right, yep. So you can start, instead of spraying and praying, you can start paying attention to what's being used, what's being viewed, how it's being viewed, what it costs you to get things to places, and start building models that allow you to dynamically manipulate your distribution and your content to maximize your business. So there's new opportunities here that weren't available before. I've seen some simple things done with this in Shanghai. NERC and Shanghai Jiaotong University have been experimenting with alternate paths for content. For example, audio tracks in different languages, watching how many people are consuming each language and deciding, here it went again, whatever, deciding when it's time to move a audio track in a language from broadband to broadcast, because all of a sudden lots of people want to consume it, and it'll be cheaper to put it there and to move something from broadcast to broadband. You know, simple example, but you can start now doing all kinds of new business models and activities based on what you're learning, because there is a return path. It gets more complicated. It's no longer as simple as pick this and send it out at 8 p.m. But you can also make some pretty big differences in your business. So I think it's worth it to start paying attention to this. It's going to take a little bit of time. We're going to have to learn how to use it, but all this is potentially available.